Dear students, today I am going to explain about Findes algorithm. Okay, in the last class we have discussed about concept learning as a task as well as concept learning as search. There we have studied about general hypothesis, specific hypothesis, how the specific hypothesis moves towards a general hypothesis. With the water sport game example we have discussed. Okay, now in this video we are going to discuss about find S algorithm. Okay, from that topic itself it is a find S. S means specific. Okay, find S algorithm. We'll see that thing. Find S. Find S means finding a maximally specific hypothesis. Finding a find indicates finding a maximally specific hypothesis. That S indicates specific hypothesis. Okay, so that is called a find S algorithm. So now we'll see the algorithm. This is one of the expected and as well as important algorithm. This is for your first lab program, find S algorithm. You should implement this algorithm using Python and you can take any data set. Okay, so first you try with this water sport game data set only. Afterwards you can give some other data set. Okay, find S algorithm. First step, initialize H to the most specific hypothesis in H. So first H is initialized to most specific hypothesis. Okay, small h. Then for each positive training instance X, for each positive training instance, it is going to consider only positive training instance X. For each attribute constraint AI in H, A suffix I indicates the attribute value in H. If the constraint A is satisfied by X, then do nothing. If it is satisfied, S do nothing. Otherwise, replace A in H by next more general constraint that is satisfied by X. That means first we are starting with specific, then we are moving towards the general. So that only given here, initialize to the most specific hypothesis, then moving towards to the more general hypothesis. Okay, after that we have to output the hypothesis H. And another thing here is only positive training instance should be considered in this find S algorithm. Okay, so this is the example already we have seen. Enjoy sport task. Here we have 6 attributes: sky, air temperature, humidity, wind, water, forecast, along with 4 data set, 4 instances are there. So the first step of find S algorithm is initialize H to the most specific hypothesis. So H equal to most specific means H equal to everything will be pi. If most general means everything will be question mark. But here that is specific, so H is defined equal to the all attribute values will be pi initialized. Then first one is x1 equal to sunny, warm, normal, strong, warm, same, positive training example. So now pi we are replacing it with sunny, warm, normal, strong, warm, same. This is positive. Then next x2 is also again positive training example. So these are all the things are there: sunny, warm, high, strong, warm, same. So now sunny, then x2 also sunny, h1 also sunny, it will take sunny value only. So then only sunny. Then next we will take warm. So warm only value only it is going to take specific. Next we will take, there are the normal and high. It can take the value normal or high for enjoy the water sport game. Okay. Then it can take any value. So question mark. The next one you will see the strong. So strong. Next warm value. Then same. So now compared to H1, H2 is more general compared to H1. Then H3, X3 we are taken. H3 will take means again the sunny it will come. This is a negative training example. No, it won't be considered for here. Then as it is we should write H3. Then X4 equal to this sunny. Then warm. Question mark high is question mark only. Strong. Warm, cool is any value warm or cool it is going to take question mark. Same or change that is question mark. So this is a more general hypothesis. H0 is a more specific hypothesis. Okay, so in that finders algorithm, we are doing like this. So here we'll take this. So there are finders algorithm. We have taken the 4 instances x1, x2, x3 and x4. Along with we found the hypothesis h0, that is more specific hypothesis. That's why it took all null values pi pi pi. Then from specific to it moves towards the general hypothesis. So H1 will take here, H1 is general compared to H0. Then H2 is more general compared to H1. H3 is more general compared to H2, H1 and H0. And H4 is more general than H3. Okay, this is the thing. That's the reason here we are given. This is it will take top to bottom. It moves from specific to general. If we take the bottom to top, it moves from general to specific. Okay, but here in the finders algorithm, the main property of finders algorithm is, key properties of finders algorithm is, finders is guaranteed to output the most specific hypothesis within H, that is consistent for positive and negative positive training examples. Okay, so this is a main thing, because finders algorithm will consider only positive training example, nowhere negative examples. Okay, so the unanswered by finders are, these are the problems in finders are, has the learner converged to the correct target concept? Why prefer the most specific hypothesis? Why we can specify the more general also, no? Why prefer the most specific hypothesis? Are the training examples are consistent? It may be consistent or inconsistent. That too it will be checked. If there are several maximally specific consistent hypotheses, what if there are several maximally specific consistent hypotheses? So that these questions are answerable by finders algorithm. Okay, and another thing is, in the finders algorithm, another drawback is when we are finding the most general hypothesis from most specific hypothesis. So we are more general hypothesis from more specific hypothesis, only positive training examples should be taken. No negative training example or training instances. That is drawback. Some we have to consider that negative, or then only we can get the good result. So that both should be considered. Okay, so that's all about this finders algorithm. In finders, the main drawback is only positive training examples are considered, no negative training examples are considered. That will be over. This issue will be solved by the algorithm, candidate elimination algorithm, that we will see in the next class.